main problem. The main problem says that you are given a binary array nums and an integer k. You have to take a sub array of length k and you have to flip the bits, which means if the bit is 0, make it 1. If it is 1, make it 0. Now, flipping bits, as soon as you hear this word, you should be able to remember as OR operation. If you have not seen the bit manipulation crash course, go and watch, right? Bit manipulation crash course by Aryan Mittal, you'll get the video. In that, we have taught all the tricks of bit manipulation. Now, coming on back, we have to tell minimum number of k bit flips, which we have to do to achieve that entire array should be 1. Ultimate aim, maksad bhulna hi nahi hai. Your entire aim is to make the entire array as 1. Now, one operation is taking a sub array of length k and then modifying that sub array of length k, flipping the entire array. Flipping, no matter what, if the array has a 1, I don't care, I will flip it to 0. So that is what I will do. Okay, now let's jump on the easier version in which the k is defined. You have to choose k as 3. K as 3 is fixed. You have to choose k consecutive elements, which means a sub array, and then flip them. So what I will do, okay, now let's say I'm starting at this 0. I know one thing for sure, it needs to be 1. It needs to be 1. If it needs to be 1, so I will have to flip k consecutive, because see, it is the starting one. It is the starting one. So no matter what, I will have to flip the k consecutive. So I will have to flip him. Okay, 1 0 0. Now this is done. This is done. Now I am landing onto here. Now you might ask, Aryan, again I see it is 0. Okay, so I have to again flip k consecutive ones. Now you will have a question, Aryan, which k consecutive ones should I flip? Obviously, you cannot touch previously whatsoever you have built. If you have done some success part, forget that. Go on, move forward. You cannot come and change things again and again, because you changed it. There could have been a chance it would have already been 1. Okay, or even if you have changed it to 1. In any case, this is completely done. If I am moving forward, my past is sorted. I know your past is not sorted, but okay. Now in this case, what I will do, okay, I think it is 0. So I have to flip it. Okay, I will flip it. And again, flipping means 3 consecutive flippings. Make it to 1, 1 and 0. Now, okay, go on to next element. It is 1. So I'm sorted. Go on to 0. It is not sorted, which means, okay, it is not correct. So again, flip it. Flip it. 1, 1, 1. Now, this was the last point up till I should go. I cannot go on to these points at all. But Aryan, why? Because you know that if you land onto this location, if ultimately this would have been a 0, you could not have flipped it, because if you would have flipped it, you would have to flip 3 consecutive ones. But I have only 2 numbers. I cannot flip it. So I can only go up till this point, which means third last point, and the remaining last 2 should be 1. If they are not 1, there is no possible way. Now you might say, Aryan, it seems greedy, but how are you so sure that greedy will give you the minimum number of operations? Okay, so let's come back. Did you have any options? Did you have any options to place to make it a 1? Did you have any other options? Obviously not. So you have to take consecutive ones. Make sense? Now, as you will take, then other will become a 0. Do you have any option rather than taking the consecutive ones again? No. You will have to take consecutive. That's one restriction. You will have to make all of them as 1. That's another restriction. That is the reason whenever I see a 0, I will have to replace it at that point only. And replacing at that point makes it that whenever I see it, I will replace it. And that what makes it a greedy problem. Cool. So we have seen that we can start from here. Then, okay, every index, look 3 consecutive ones, flip all of them. If something is 0, look that and flip all of them, 3 consecutive ones. So it will be n into 3 as the time complexity. Okay, let's see the code. It's exactly same. Firstly, I took my n and my answer is the number of flips. I did what? I went on to less than n minus 2. I left last 2 elements because I know no matter what, ultimately which means n minus 2, nums of n minus 2 and nums of n minus 1 should be 1. If they are 0 ultimately in the end, answer is -1. I was not able to modify them. Sorry. So what I did, I went up till last third element. I checked if it is 1, simply continue. I don't want to worry about it. If it is a 0, then flip the next, which means flip these 3 consecutive numbers. I will flip them again. Flipping is simply XOR operation. You can also put a minus operation. It's totally up to you, but you can see it's a simple XOR operation. Ultimately, as you have done one flip, as you have done one, when I say one flip, I mean one consecutive array flip, answer increased by 1, and ultimately this is your answer. Now as you can see, you iterated on n, and this is only thrice. That's it, only thrice. N, again this is, you can say k, but k was fixed to 3, so complexity is n into k, but it is n into 3, which is n only. So your time complexity is O of n. But as you can see, you are modifying the input array also, which is kind of not a good thing. So you will have to incorporate that space also. Now this seems good. Okay, O of n and space of O of n. So this will for sure obviously work, because if we look at the constraints, okay, constraints are gone, but yeah, O of n and O of n will work. But if I apply the same thing on my hard version, I know the complexity would have been O of n into k, because in the hard version there is no k is not fixed. I have to choose for any possible k, and k, they are mentioned that it is up till num's length, so it will be n into k's time complexity for the hard version, which will for sure give TLE. So we one thing for sure, okay, this approach which we saw, which followed for 3191, this will not be followed in our hard problem. But before going on to that, let's quickly see another variation of the above problem which we saw. In that variation, it says that from index I, now rather than flipping 3 consecutive numbers, you can flip from index I up till the super end. So if this is the array, now rather than having an option of flipping 3 consecutive numbers, I can, okay, at index I can flip the entire range from start up till end. This is the entire flip which I can do. Okay, now in that case, again the same thing, that if I am landing onto 0, I have to make it to 1. There's no option. I cannot make it remain 0. Sorry, I cannot make it remain a 0. Yeah. So if I am standing here at this index, I will have to replace it to 1. I have to replace it to 1. So I will replace it to 1. If I am doing that, I have to make sure this replace is for the entire array up till end. So I have to replace, or I have to flip all of them, 0 0 1 0. All of them are flipped. Okay, one operation done. Next operation, I will go on to this index. In this index, again, this is 0. It has to again be flipped. I will flip it, make it a 1. All of them up till end should be flipped again. 1 0 and 1. This is 1, ignore it. This is 0. This is 0 again. Starting from here, this should be flipped, and all of them should also be flipped. Okay, this again, this is 0. Flip it. If I flip it, it will become 1. So you see, I flipped it 1 2 3 4. I flipped 4 times. That's the answer for me is 4. Same way you did, same way, because you know you will have to flip, and there's no other option. You cannot go backwards again, so you have to flip it right now only, and that's what make it greedy again. If that's greedy, what's the complexity? At every index, you are flipping the entire array up till end. Every index, you flip the entire array up till end. So complexity is n into, you can say roughly n, because entire array up till end. If I look at the constraints, n into n, O of n square will not work. Then what? Okay, that makes sense. O of n square will not work. That was true. But do I need to flip all of, again, if I don't erase it, do I need to flip them again and again? As you can see, here 0 was flipped to 1. Okay. Here 1 was flipped back to 1. Okay. Here the 0 was flipped ultimately to 1. So it is kind of that a number, I'm just trying to monitor how many times that number got flipped. This is the best part about binary numbers. The number says binary. It can go from 0 to 1, 1 to 0. This trick is also used in rotation of arrays. If I rotate the array n times, so an element, again, an array after rotation can have only, again, if I just give you, again, that's a slight diversion from the actual topic, but a quick hint for you that how you can use this trick everywhere. That if you have this array, if I ask you, give me the location of the maximum element after n rotations, and it can be very large, like 1e9, 1e15, like that. So you know that even if I rotate any number of times, its location can be this or this or this or this, right? Either it can come at the index 2, index 1, or index 0. That's it. So you have only possible 3 indexes. So other rotations will only bring it to these 3 indexes only. So that is how we use modulo operation in this rotation points. But here in this case, you can see I can have either my bit from 0, it can either become 1, or it can remain a 0, or it can remain a 1, right? So if that is the case, I just need to know if the number is 0, if I flip it odd number of times, it will become a 1, right? If I have a number 1, if I flip it odd number of times, it will become a 0. If I have a number 0, if I flip it even number of times, it will remain a 0. If I have a number 1, if I flip it even number of times, it will remain a 1. So this is, I just need to maintain the frequency or the times, number of times anything should be flipped. Thus, I don't need to flip at that point only. What I mean by that is, I will just say, okay, this was a 0, which means I have to flip it, which means that the remaining numbers should be flipped. But I have flipped it just once, so remaining numbers should be flipped once. Okay. Now, as I land onto this location, firstly, I should tell what is the current value of it. Because see, again, this 1 is not indicating that its correct value. Its correct value is after flipping this number of times. Okay, so if I have a 1, I know that if I have a 1, if it flips odd number of times, then it reaches to the other side, which is 0, and this is even. So I realize, okay, my times is odd, which means this 1 will ideally become a 0, and 0 I cannot entertain, so I have to flip it again. If I flip it again, so it should, after flipping it again, it will become a 1, which means now my flip times has become 2. Okay, when I land onto this one again, this one, now this one is flipped even number of times, so it will remain a 1, and I wanted 1, so I can move on. Now I land onto this 0 again. This 0, it is flipped even number of times, which means it will remain a 0, but I wanted a 1, so I have to flip it again. So now the times became odd, and this has become even. Sorry, this has become a 1 because I have to flip it. So this indicates how many times something has flipped, and you see that as I go on, this will remain intact because I had to flip the entire subarray up till end. Okay, then ultimately I reached 1. Flipping it odd number of times, I would reach a 0. If I reach a 0, that was not good. I have to make it to 1. If I have to make it 1, I have to again flip it 4 number of times. Thus, this will be flipped. So you see, I just maintained a variable called as times, how many times my sub array up till end should be flipped, and I'm just adding my number of times in my times variable. And that is the crux, that how you can solve it in O of n time by just maintaining your times array. Cool. So times variable. So I just maintain my times variable, and this is the answer. Answer is not needed because the times will give you ultimately how many times you actually flipped your array. But you can take this answer also. It's totally up to you. Now, if you are at a specific index, you will go into all the indexes for sure. If you are at a specific index, if the nums of I is 1 and you are flipping it odd number of times, nums of I is 1, flipping it odd number of times, you know that this will become as 0. If this will become as 0, you will have to increase, you will have to flip it again, which means times will increase. Or if you are at 0, if the nums of I is 0 and the times is even, which means it will remain as 0. If it remains as 0, again you will have to flip it, and again in this case also I increase my times. So ultimately I got my times. Remember one thing, in this question there was no scenario of leaving the end portion, because there is no sub array concept. It is the entire array from the index up till the end, array up till the end, index up till the end. This is how this is designed. That's the reason I was able to go on to all the indexes up till the end. Cool. And ultimately I was able to get the times, and as you can see, I iterated on simple array O of n time, and I also was able to achieve this in O of 1 space. So the times O of n and space O of 1. Now you might say, Aryan, this was not linked to the above problem technically, which means if I see the 3191, it asked for a consecutive array of size 3, a sub array of size 3. Then this said a sub array, not a sub array, but an array from index I up till the end. But the actual problem, which was the hard version 995, it again came back to the sub array, but now of a size k. And again, here he also has the same aim, make the entire array as one. Now we will use both the techniques which we learned above and try to optimize, because we know if we use 3191 approach in the 995 approach, in the 995 problem, then we know the complexity will be n into k, which will for sure give TLE. I have to optimize it. How to optimize it? Let's see now. So one thing we realized that greedy will have to go about it. So let's go. Now in this example, my k is 3. So sub array size will for sure be 3. Okay. I am at this index. I will have to make it a 1. If I have to make it a 1, technically I will have to replace all of them to 1. Okay. Now answer became, again, right now I'm just showing you the brute force one, which means, okay, n into k1. Answer became a 1. Now you're at this index. Value is 1, ignore it, move on. Value is 1, ignore it, move on. Value is 1, ignore it, move on. Value is 0. Replace the entire one. 1, 0, 0. Okay. You are here. Again, answer increased to 2. Again, it's a 0. Replace it to 1. Replace it to 1, which means this will become a 1. This will become a 1 because this was a 0, and this will become a 1. And again, you have to stop here only. As I told you earlier, when we saw 3191, we saw that the array size, we have to remain it to 3. Like we have to leave it. We have to leave that portion. So I have to leave this, because if no matter whatsoever value comes here, if this is a 1, I'm good. If this is a 0, I was not able to change it. I will not be able to change it, because if I try to change something which is let's say ultimately here I got a 0, if I try to change it, I need a sub array of size 3. I don't have that much big length, so I have to stop here only. And ultimately I know that I have got this as 1 1, so I'm good. Now in this case, it's obvious, right? One thing, that how many times you did change, you for sure did change like 3 times. But now the issue was you cannot just keep on changing the entire array k. That's big. So what I can do one thing, that I can use the technique which we saw in 3192, this problem, where I was maintaining my times, which means I was maintaining my count of how many times I should flip something. Okay, let's try the same thing here also. That okay, I will maintain the times count. The times will tell me how many times I should flip something. Okay, 0, I should flip it. Okay, obviously it is 0, I need to flip it, so I'll increase my times to 1. I will flip it. I will land onto the 0. My time says 1, which means flip it. 0 will become a 1 now, and it is good. I need a 1. Okay, so answer was only increased when the 0 was flipped. This at this location index 1, it will be a 1 because of my times. Okay, this will remain a 1. The array will remain 1 as it is, which means no impact. At this point, again, my times was 1. My count, my number of times was 1. So I need to flip this 0 to 1. Okay, this will be flipped. This is 1. My time says 1. So technically, because of my time says 1, I have to flip it odd number of times. Flipping it odd number of times makes my 1 to a 0. Now, if it has become a 0, so I should replace it back to 1. So I will increase my answer, and I will also increase my times. Is it correct? Obviously, it is not, because your sub array ended here only, which means the impact of this times ended exactly at this point. Impact of times was not here, which means as soon as the times came here, I should, if you remembered up till this point, the times was 1. As soon as it comes here, the time should go back to 0. I should not take my times beyond the array of size k. Oh, that's an issue. Earlier I was able to take it because it was up till the end. So I was able to take my times, but now I cannot take it. I have to make sure that whatsoever times I have, like, it should get the correct times value. In this case, the correct time value was 0. So now in this case, what we realized was we need something of the sort that technically I don't need my times value. My times value was a 1 here. So I know that the array ended here, which means if I can maintain if I had flipped something at this point, if I can maintain, because see, you remembered the actual thing which you did was you flipped at this point only, and you said, okay, I flipped it here. Then you did, because of a times, you did not flip here, you did not flip here. Then you came here, you realized the array was ended. If the array is ended, if I can go back to this and ask, okay, bro, you told that again, and how I'm going back? If I am at the index I, I'm going to index I minus k, which is just outside my window, or basically saying I have now got outside my window. So I went on to this number and asked him, bro, did you flip something? If yes, then you should not give me that flip. So I will ask him, bro, did you flip something? If yes, bro, please don't give me that flip. So I will go and ask him I minus k. I asked him, bro, okay, you flipped something. If you flipped something, so please don't give me, and I will reduce that flip from me. Now my times became a 0. Now the number is 1, times is a 0. So okay, I will not flip. I should not flip it, because flipping number 1 even number of times makes the same number. So 1 will remain 1, and that's what I want. Okay, go on next. Now my I is here. Technically, I again should ask my window of previous window. I will again ask my previous window, and I should go back to my I minus k. I will ask him, bro, did you flip something? He will say, no, bro, I did not flip something. So my times will remain 0 only. Okay, but now it is a 0. 0 needs to be flipped. 0 needs to be flipped. If the 0 needs to be flipped, then what? Increase the times by 1. Obviously, you will flip it. And when you will flip it, you know that you will monitor. Let's maintain a variable called as is flipped. Maintain the variable as, or maintain the vector as is flipped. It's a vector, or basically an array. Let's say an array. Now, if you maintain an array of is flipped, you told, okay, this number should be flipped because it was a 0. My times said, I have my times, and how I found my times, I minus k, and I will go and check at I minus k how many times I flipped it, and I should remove that number of times I have flipped it, and I will get, okay, I will get no times flipped so far. The times is 0. It is a 0. It needs to flip to become a 1. So I will flip it 1 time. Okay, 1 time I flipped. Now my time became 1, and I should mark here also that I flipped something. Okay, now let's go on. Again, I am at index 5. I have to go and check at I minus k. 5 minus 3. I'll go and check the index 2, which tells me that the array has ended. Times number of flipped is 1. Did you flip something, bro? He will say, no, bro, I did not flip anything. So I will not reduce my flip by any number. My times will remain 1. Number is 1. It will flip 1 time, which means odd number of times flipping a number. It will become to a 0. If 1 became a 0, I don't want a 0. So I have to flip it back to 1, which means I have to increase my times to 2. And this became a 1. And again, as I flipped at this point, I have to mark, okay, I flipped at this point. Okay, move on. But Aryan, you said not to not move on. Bro, you will have to move on and check others, because earlier approaches you were flipping. When you were at I, you were flipping the later part, but now you have not even touched or checked this part. So firstly, I came here. Now to check the actual number of times this location was flipped, again, if this is index I, go to the index I minus k and check, because this is a window, and check how many times this number should be flipped. It will say, bro, I did not flip anything, so don't reduce anything. So I will not reduce anything from my times. Times will remain 2 only. If the times is 2, I know that 1 should be flipped even number of times. Flipping 1 even number of times make it a 1 only. So no flip required here also. Okay, move on here. I. Okay, firstly check I minus k, because this is the window. Oh, window said, bro, at this location I flipped, and now you are at this current window, which means you should remove the existence of flip from index 4. Yeah, so I have to reduce the count of 1. So I will remove the count of 1. I'll do a minus 1. My times, number of flip times should be reduced to 1. It will become a 1. So this number 0 should be flipped odd number of times. flipping a 0 odd number of times will make it a 1. So I don't need a flip here also. I don't need a flip here also. And then I can simply move on. Thus, you realize one thing. But Aryan, how will you check the -1 case? See, -1 case would be checked if this would have been a 1. My times was odd. So flipping this would have resulted in a 0 value. And for the last these characters or these indexes, I cannot flip. So if in the last locations, if after flipping I get a 0, and again when I say after flipping, I mean flipping times number of times, I get a 0, I have to return a -1. Now let's quickly see a code. Again, with code you will get much more understanding, because see, this is actually a bit complicated to even think of that how you'll incorporate. But here we used a simple prefix technique, like kind of a sliding window technique, that maybe I can use my previous state and check did I flip at that point or not. Cool. Let's see the code. The code simply says, I'll go on to all the indexes. I will maintain flipped. How many times I flipped something, or basically like did I flip at that index or not. This is did I flip at that index or not. This will store the same number of times, how many times I flipped something. Then I go on to all the indexes. Again, the exact same condition. If the nums of I is 1 and the times is odd, which means the nums of I will become even, means 0. If the nums of I is 0 and the times is even, which means it will remain a 0. In this case, I should flip. And when I say I should flip, I will flip at that index and will mark, okay, I flipped at that index. I will increase the times, number of times I flipped something. I'll increase my answer also. Because Aryan, why did you have to keep track of both answer and flip? Because you realized that my times will decrease also. My times will decrease also as I move my window. So I have to maintain the actual answer also. And in that case, we also realized that if in any case you have reached the end boundary, if you are at an index I, that you have to flip it and the window size exceeds n. The window size exceeds n, which means here if something comes inside the if loop, which means we have to flip it. Now this condition says that you're at an index I, that if I make a window from that index, it will exceed n. In that case, bro, was screwed up. So in that case, return a -1. Else increase the answer, increase the number of times you have to flip, or basically increase the number of times, that current number of times something has flipped. And thus, simple case that you can start decreasing, as it's a simple window, sliding window technique, that I can go to index I minus k. If I am standing on the index I can go to index I minus k. If I'm standing in index I can go to index I minus k. But if I'm at the index I here, there is no I minus k. So in that case, simply you cannot do. So here, that same thing, that if the I is more than equal to k, only then you can actually reduce from your times, that if you flipped something at index I minus k or not. And with this technique, you can simply get your answer in O of n time only. O of n time. But you see that you have used a space of O of n also, which is the flipped array. Now, my question is, can you improvise it? Can you improvise it? Which means that I am asking you to not use this flipped array. O of n time will for sure be taken, but can you improvise the space? Which means I'm asking you to not take the actual space of flipped array. Somehow you cannot use the space, like is flipped. But then if I cannot use this, then how? If I'm standing at the index I should be able to know that index I minus k was flipped or not. That's the only task which you have to find out. In that case, if you're at index I, if you cannot use this array, but you still have to somehow know that did you flip this index I minus k or not, then why not modify the nums array? Whenever I will, again, if you remember, this was a 0. So sorry, this was a 1. Sorry, 0, yeah. So I will do one thing. Whenever I know I have to flip this, okay, at nums of I, it is a 0. So rather than making another vector or another array as saying, okay, this was flipped or not, I will modify the nums of 0 itself and will say, okay, bro, modify this nums of 0 to a value which is not inside the array. Inside the array, I only have a 0 and a 1. So I'll modify it to 2. So I'll modify it to 2 and will tell that. And if I'm standing at the index I, I'll go back and check nums of I minus k. If this is more than, if this is more than my actual value, if this is more than my actual value, which means either 0 or a 1, if this is more than 1, I know this bit was flipped. In that case, simply reduce your count, reduce your times by 1. Then you might say, Aryan, yeah, this makes sense, it will work. So Aryan, are you saying that you will put 0 to 1 and 1 to also, again, as you can see, 1 was also flipped in this case, so 1 to also 2? You can do it, but Aryan, like, this is cheating, right? Earlier you told that if you modify the input array, it is not a good practice. So this will again count as O of n space. You are right, I was cheating. Not, because, okay, if I know that when I was flipping this 0th bit, I modified it to 0 to 2. When I am at this index and I check that is nums of I more than 1, which means that bit was flipped, I can flip it back to, or I can make it back to a 0. How? I know, firstly I will check if this was flipped. If yes, okay, then, and if yes, which means the value would have been 2 or maybe more than 1. Then I will bring it back and will reduce a 2 and will bring it back to a 0. But then Aryan, you are saying that your nums of I minus k will be a 2, and you know that you have to subtract a 2 and then you will get a 0. But in this case, when you modified your nums of I minus k to a 2, if you subtract it back to a 2, then you will get a 0. But the actual value was a 1. You are cheating. I can say that, but what I will do is, in this case, when I will modify, or basically I have to flip at this location, index 5, and the nums is 1, so I'll add a plus 2. So I will make it a 3. And then when I am at specific index, when I'm at a specific index, I will go and check back. I'll go and check back and will say, bro, did I flip this? If yes, did I flip this? As in, like, I'll go and check at the index I minus k, and I will simply do a minus 2. This will become a 1 back. So by just adding a plus 2, I was able to say if something was flipped, and when I'm checking back at I minus k, I will check if this was flipped. If yes, then do a minus 2 back and then get the original value, and thus my array will remain intact. Cool. Let's see the code. It's exactly same code as we saw previously. It is just the simple change that I removed my is flipped vector. Now I had a simple check. Again, if you remembered the existing, your existing check was, you just simply was reducing in your times array flipped of I minus k. But now I will do one thing. I will check if the nums of I minus k, if it is more than 1, which means that I minus kth location was flipped. In that case, firstly, reduce the nums of I minus k. Now, when this is reduced, make sure to also reduce the time by 1, because that's what your is flipped function was doing. And the same way here, rather than having a flipped plus equal to 1, or basically if you see, I was putting a flipped equal to 1, I will simply say nums of I plus equal to 2, which means at the ith location, if it is flipped, I will actually add a plus 2 in my nums of I. And then when I will go and check my another I, which is in future, I'll check for I minus k and check if this was flipped. I will reverse it back to its original value. There's one small case which I did not write here, but as we saw a dry run, it was very evident that when the array is ended, there's a chance that this index, which is if the n is 8, n minus kth index would also have been flipped, but that would not have been counted. So just have a quick change here, like quick add after this for loop, add a if condition. If your nums of n minus k, if this is more than 1, then also make sure to do a nums of n minus k minus is equals to 2, so that you flip your nums of n minus k index also. So that's one condition which I mentioned, like which I forgot. But with this, your nums of I will remain intact. You use your nums of I, but then you put its value back, and thus you got a space of O of 1. Time is still O of n because you have to go to all the elements. Cool. I hope you guys got it. Again, this is a very good problem, and because of the fact that how easily it can, because see, I started with one problem and I showed its 3 follow-ups. So it's actually very cool. Bye bye. Take care. I hope you got it. Bye bye. Nice. And please do subscribe if you liked it. If you like it, please at least like, comment what you learned, because every time you write something, you will remember that you learned this. So I always recommend, write what you learned from this video. Bye bye. Take care.